very much chemistry. We're going to emerge here. These are our learning outcomes for today. We need to identify what the major air pollutants are. You're going to try to implement those and memorize those, commit them to memory in the same way we did with a lot of the water pollutants. The second thing is describe what are those sources of air pollution. So we'll be filling out a table similar to what we did with water pollution to help get that firmly cemented. And then we're going to look specifically at photochemical smog as a process, some complex pieces of that. And then we're going to talk about acid deposition, primarily starting in our lab tomorrow. I'm going to kind of leave that. Photochemical smog and these other issues are going to be our primary focus, and we'll deal with this a little bit when we get into the lab session for tomorrow. Sources of air pollution. Like I said, humans are a little bit unique, but there are natural sources of air pollution that act. Volcanoes, native forest fires, windstorms pick up dust and blow it around. We have dirt particles that are suspended in air. We have plants that produce pollen, which can be breathed, cause respiratory issues not only for humans, but for animals. You're seeing that probably right now, and increasingly as spring gets underway, I think it's going to be a fast and furious spring. The pollen always hits people in St. Louis, but mold can do the same kind of thing. And then we have ocean deposits kick into the air. We've seen the influence of salinity. Plants can only tolerate, organisms can only tolerate salts within a certain range, and so that's a principle that we're familiar with. While those exist, we're primarily going to be focused on human anthropogenic causes. Again, as a reminder on this word, because it felt like it snagged a couple people on the last assessment, but it shouldn't. We've used this word many times. But anthro is the root word for human, and progenic means it's produced. The genesis or the beginning production was human. So we're talking about humans who have created these sources of pollution. Here's what they look like. It's exactly what you would assume. Transportation, industry, generation, and then waste disposal. So all of these places, all of these sources can cause air pollution, and there are really only going to be a couple air pollutants that we're going to be focused on. They fall into two categories, and this piece is going to be really important. We're going to get into the chemistry a little bit here, but we have primary pollutants. So when you hear primary, that means they're the original pollutant that's out in the environment, directly from the source. You should think about these being of a smokestack or an exhaust pipe or other sources like that. It's the direct source. It's never the pollutant that goes out into the atmosphere or into the environment directly from those sources. This is what they look like. Again, start committing these to memory because you're going to be asked to know about these specific ones. Hydrocarbons, carbon and hydrogen chains, nitrogen oxides. So you'll see that typically notated as NOx, meaning it could be NO2, NO3, NO4. Stable form, but all these forms of nitrogen and oxygen together. Sulfur oxides, which is similar. So you'll see sulfuric acid, sulfur dioxide, etc. Carbon oxides, you'll see carbon monoxide, carbon dioxide, etc. But carbon and oxygen together, and then particulate matter. So we're looking at about 5 primary sources. Secondary sources, just to kind of put them out there, and I have a little bit of the chemical elements here for us to see, but these are new pollutants that are formed in the environment from primary pollutants. So first primary pollutants are kicked out into the atmosphere, and go usually a series of chemical reactions, and they form new pollutants that are often much more harmful than the primary pollutants. So we have two sides of this we have to work out. The source pollution, and then this secondary pollution. These are photochemical oxidants. We'll talk about that. And then we'll look at nitric acids, especially, and sulfuric acids, especially in our lab tomorrow. So we have primary and secondary pollutants. I really like this flow chart, and I feel like this is a really nice study tool to help walk through it. Let's go through it one element at a time. I didn't have a way to make the animation click down, but focus on it like this. So here are some human sources. And again, there are natural volcanoes, forest fires, etc. But we're going to think about human sources for the most part. Cars, combustion engines, they have waste products that are produced. Industry, smokestacks, electricity generation, especially from fossil fuels, those produce pollutants as well. Those go out into the environment. When we're looking at these primary pollutants, there are other pollutants like the coal ash. So burning fossil fuels also produces water pollution. But here we see that there's air pollution that's produced as well. So here are all the sources. Nothing new here, really. These are the ones that you saw from the previous slide, with the exception of chlorofluorocarbons, which we'll talk a lot about when we look at ozone soon. But all of these are primary pollutants, and they come from these sources. The second thing that happens is they combine with other elements and especially environmental conditions. Things like water vapor, things like sunlight, and they produce these other secondary pollutants that are actually much more harmful. Things like acid rain. I'm sure you've heard of that before. Sulfurous smog, that's what we're going to talk about soon. And then they cause all of these effects. So we're going to think about what I like about this thing is it shows you have all these pollutants and they cause some harm, and then some of them cause some extra harm, and then the harm stratifies essentially global warming, which is huge. Talk about human health, ecosystem damage, and ozone. So we have these couple places where the harm resides. Everybody feels okay about this? Let's look at it from a process. When we look at the proportions that come from these different sources, it's primarily industry. And by the way, industry here includes electricity generation. So these sources of air pollution, a lot of this, about half of it, comes from the production of electricity and other industrial sources. The materials that are used to make textiles and goods and chemicals that we use in all kinds of ways, making clothing, making cars, but then electricity generation. And then we have the next biggest one is transportation. So all of us who drive cars, but also including trains, airplanes, etc. That makes up about another third. So between industry and cars alone, these are the big targets. So when we talk about controlling these sources, remember this distribution because it kind of matters. If you really want to reduce air pollution, you don't really want to focus on commercial heating that much. It's a really small percentage. We want to focus on electricity generation and burning of fossil fuels, and then consumer products and agriculture. Oh, where's my mouse? There we go. I wanted to put this in here as a way that would kind of make sense. And if you're a type of person who wants to copy some things verbatim, this is the slide to do that. Primary pollutants, directly from the source. These are the kinds, and this is where they come from. And the same with secondary pollutions. I'll leave this up here for a second if you're a person who wants to copy it down, because it's really key. But I also want to mention table 46.1 in the text is really course. It has all of these in where carbon dioxide is specifically produced. When you fill out your table that we're going to do like you did with the water pollution, that's the page you turn to. Really key. Anybody need me to leave this up here anymore? Or we're good? I'll leave it for a second here. This is a mistake, by the way. It should be O2. H2O at. Yeah. Up for about 15 minutes, move on. We'll have the slides available on campus if you need to turn back to it. This is one of those to memory, or to begin to commit to memory here. All right, beautiful. Let's keep going. I want to show this video really quick, and I have think about watch the video. Understanding about photochemical smog is actually, it's fairly recent, and it helps us understand the scientific processes behind these observations and how do we figure out not only what the pollutants were, how do they form in the environment, what harm. So we're going to watch this, and I want you to answer these questions. How do we understand what the word smog means? A little bit about the pollutants, but especially 3 through 6, the environmental factors that need to be available in order to produce smog. The elements of volatile organic compounds are going to give you a short list. The geographical factors that can increase the risk of smog. So those are things like how does the topography of the land look, etc. And then how is smog reduced in London? A little bit of a policy piece. Here we go.
On July 26, 1943, Los Angeles was blanketed by a thick gas that stung people's eyes and blocked out the sun. Panicked residents believed their city had been attacked using chemical warfare. But the cloud wasn't an act of war. It was smog. A portmanteau of smoke and fog, the word smog was coined at the beginning of the 20th century to describe the thick gray haze that covered cities such as London, Glasgow, and Edinburgh. This industrial smog was known to form when smoke from coal-burning home stoves and factories combined with moisture in the air. But the smog behind the LA panic was different. It was yellowish with a chemical odor. Since the city didn't burn much coal, its cause would remain a mystery until a chemist named Ari Hagenschmidt identified 2 culprits: volatile organic compounds, or VOCs, and nitrogen oxides. VOCs are compounds that easily become vapors and may contain elements such as carbon, oxygen, hydrogen, chlorine, and sulfur.
Let me pause here just so you can write them down. Carbon, oxygen, hydrogen, chlorine, and sulfur. This is the list of volatile organic compounds. Just to give you a little bit of information, volatile means their chemical structure is not very stable. Can go back in states of so they can change from liquid to gas is a great example. So that's what the volatile piece means, organic. We're talking about usually they have carbon and hydrogen and oxygen in them, but the carbon is always key, and then they're compounds. So they can be really complex in their structure, but they usually have these. Do I want you to know these specific ones? The answer is yes. If you see something around chlorine and carbon and oxygen together, you should be able to identify that that is a volatile organic compound. Let's keep going. Yeah. Oh, yeah.
Yeah, so for the source of pollution,
so here at the beginning, and this hopefully at the end as well, they were using coal to heat up houses at the time when they first found it. We use coal still in a really similar way to produce electricity, right? But the big that people thought it was chemical warfare. So it was a pretty big issue. It's pretty harmful stuff. Let's keep going.
Some are naturally produced by plants and animals, but others come from man-made sources like solvents, paints, glues, and petroleum. Meanwhile, the incomplete combustion of gas in motor vehicles releases nitrogen oxide. That's what gives this type of yellowish color. VOCs and nitrogen oxide react with sunlight to produce secondary pollutants called PANs and tropospheric or ground-level ozone. PANs and ozone cause eye irritation and damage lung tissue. Both are key ingredients in photochemical smog, which is what had been plaguing LA. So why does smog affect some cities but not others? Both industrial and photochemical smog combine man-made pollution with local weather and geography. London's high humidity made it a prime location for industrial smog. Photochemical smog is strongest in urban areas with calm winds and dry, warm, sunny weather. The ultraviolet radiation from sunlight provides the energy necessary to break down molecules that contribute to smog formation. Cities surrounded by mountains, like LA, or lying in a basin, like Beijing, are also especially vulnerable to smog, since there's nowhere for it to dissipate. That's also partially due to a phenomenon known as temperature inversion, where instead of warm air continuously rising upward, a pollution-filled layer of air remains trapped near the Earth's surface by a slightly warmer layer above. Smog isn't just an aesthetic eyesore. Both forms of smog irritate the eyes, nose, and throat, exacerbate conditions like asthma and emphysema, and increase the risk of respiratory infections like bronchitis. Smog can be especially harmful to young children and older people, and exposure in pregnant women has been linked to low birth weight and potential birth defects. Secondary pollutants found in photochemical smog can damage and weaken crops and decrease yield, making them more susceptible to insects. Yet for decades, smog was seen as the inevitable price of civilization. Londoners had become accustomed to the notorious pea soup fog swirling over their streets until 1952, when the Great Smog of London shut down all transportation in the city for days and caused more than 4,000 respiratory deaths. As a result, the Clean Air Act of 1950 banned burning coal in certain areas of the city, leading to a massive reduction in smog. Similarly, regulations on vehicle emissions and gas content in the U.S. reduced the volatile compounds in the air and smog levels along with them. Smog remains a major problem around the world. Countries like China and Poland that depend on coal for energy experience high levels of industrial smog. Photochemical smog and airborne particles from vehicle emissions affect many rapidly developing cities, from Mexico City and Santiago to New Delhi and Tehran. Governments have tried many methods to tackle it, such as banning cars from driving for days at a time. As more than half of the world crowds into cities, considering a shift to mass transit and away from fossil fuels may allow us to breathe easier. The author of the TED lesson.
All right, so let's check out a couple of these things really quick, and then we're going to dig into the details a little bit more. What we're looking at is incomplete combustion of fossil fuels for electricity production in heat and cold, and then also in transportation. So when we looked at energy generation, a lot of people say we want this know much about what those air pollutants are, but here they are, and this is this harm that they can cause. The environmental factors needed, well, you need a lot of sunlight, you might need water vapor, depending on the composition of those amount of sunlight or amount of moisture can affect the amount of smog or the type of smog that's actually formed, and the type of harm that comes from that. So you have all of the chemical stuff, which is, here's the primary and secondary pollution in the environment, and then you have some geographical things that matter. If you don't have a lot of, because there's a mountain range in the way, and you can't sweep away those pollutants, it exacerbates the issue. If you have a lot of water vapor near the ocean, like it is for Glasgow or London, then you increase your amount of smog. So we have the chemical piece, and then we have the geographical piece, and that helps categorize these. Hopefully you got a couple of the chemical elements. Those are going to be key to understand. So sulfurous smog is one of these categories. They mentioned it in this film. It's gray or industrial smog. It's some of the worst smog that exists, and you usually find it in places, I put a bunch of countries here, but there are areas in the United States, like in the eastern United States, although across the whole country, it's not as much of a problem. But in China, Eastern Europe, London, historically, these have been big issues. Why? It's because the weather is cool and damp. That extra water vapor that's usually associated with close proximity to ocean or spring or seas, that combines with the particulates and the sulfur dioxide, and it holds these primary pollutants in place, and it usually comes from coal burning or other fossil fuels. The weather and the pollutants together, that's what creates this sulfurous smog. So here's a nice picture. This picture isn't doctored. This is what it actually looked like in London recently. Photochemical smog. Again, the sources are a little bit different. Usually more associated with vehicles. So it showed up in California as an example. This is also known as brown smog. This is found in a lot of places like India, in LA, in Mexico City. The weather is sunny. It's not as cloudy. There's not as much water vapor in the air. and it's composed of nitrogen oxides, ozones, and other hydrocarbons. Hydrocarbons and all of these associated with impartial combustion of fossil fuels in car engines, result of gasoline emissions along with ultraviolet radiation. What's interesting here is when we think about the solutions to this, higher efficiency engines is a good solution. It's helped quite a bit with this. It reduces the amount of impartial combustion. You also get more mileage in your vehicle, but that helps reduce it. A lot of people think, oh, the LA sunsets look really beautiful. That's because the smog holds the sunlight and it allows you to look at the sun and see the colors and reflecting, but what you're looking at is air pollution. So I don't know if that affects your ability to perceive the beauty or not, but that's what we're talking about. Okay, be diligent here on this slide with me. This is some chemistry and you have to know it. You have to understand it. We're going to these processes and then I'm going to show a flow chart of the actual one. But the formation, when fossil fuels are burned, the pollutant, so it's the combustion and the heat that's generated for electricity or gasoline for transportation. But here are some of the pollutants that come out of it, hydrocarbons and nitric acids. Look at this process. When they're built up in high concentrations, the primary pollutant, like the nitrous oxide here, is combined with free oxygen in the environment and produces NO2. Then we add, why is my number 3 not here? I'm not sure why that did that. They absorb sunlight, and it breaks the NO2 into NO and free oxygen again. So we have some back and forth happening here. So the big point I want to make here is once it goes into the environment, it doesn't break down through this process. It moves back and forth, and so it starts as pollution, and it continues to contribute as a pollutant for quite a long time. Free oxygen combines then with atmospheric oxygen, the way you typically find it, and it produces ozone. Ozone in the troposphere is toxic when you breathe it. Oxygen is respiration, but ozone cannot be utilized by the body. And then nitrous oxide, again that's still out there, combines with ozone again and makes NO2 and oxygen. And what you can see is this process goes back and forth over and over and over again. So the secondary pollutants that can be formed, we end up with a lot of toxic things like formaldehyde. So we're combining together some of these hydrocarbons with ozone that's out there. We produce formaldehyde in water. Another one, acrolein. Another one, I'm just going to call this PAN so we don't get bogged down on the chemical name here, but they mentioned that. So we have these 3, formaldehyde, acrolein, and PANs. These are toxic as well. You're going to see these referenced when we look at the environmental harm piece. So now let's look at this kind of as a flow chart. So for example, natural and anthropogenic sources, but primarily we're most concerned with organic sources. And we make ozone. Ozone combines again with the nitrogen oxide and oxygen and creates NO2. And then we produce all kinds of things, including photochemical smog when it's combined with volatile organic compounds. So we have all of these pollutants kind of combining together, and in their secondary pollutant form, this is when they're causing the most harm. I want to do a little justice to thermal inversions that they mentioned just so we can make sense of it in our mind, because the geographic piece really matters. We have much fewer cars in St. Louis than in Denver, but in Denver they have a huge problem with smog. Here we don't really have the same problem. It's because the geography is different. In LA, they have a lot of vehicles plus unique geography, and then it allows for the chemical smog to be even worse. So this is kind of what it looks like. The cool ocean air is combined under a ring of warm air, and it's trapped by a ring of the mountains. So here you can see the cool air, it traps this air of warm air. This is why it's called a thermal inversion, because you have warm air beneath the air, and usually you would have the warm air on top, right? But it's because the breeze is coming in. In these coastal areas, the breeze comes on, and you get this little cyclical motion. So it gets worse throughout the day. The air comes in and it accumulates in the area where it's trapped and pinned up against the mountains. And these are the comes from cars especially, but in the evening it usually gets a little bit worse because the conditions, both environmentally and the amount of pollutants being pumped out, cars usually are both lower, and therefore you end up with less pollution during those times. So the big idea with thermal inversion is you just have that cool air, the cool air that's trapping the warm air, and then you get this little tiny cycle, and because of usually a mountain range, they get trapped. So if you don't have ocean access and you don't have mountains, you don't get this issue, but there are a lot of places in the world that are on the coast, and because of the way coastal and continental plates join together, there's usually mountain ranges right there. So thermal inversions is in India and in the United States. Let's just look at these hazards really quick. What kind of harm did pollutants cause? Commit them to memory. This is what we're looking at. Both ozone and PANs are powerful eye irritants, and we're not talking about like a little bit of stinging. We're talking about the thing that makes people think that they're under a chemical warfare attack. When we talked about photochemical smog, it can be pretty serious. The concentrations are high. It's really bad. Ozone and nitric oxide also irritate the nose and throat. So we have some burning. If you're immunocompromised and you're already prone to infection, this exact photochemical smog damages building materials, especially things that are made out of material like rubber. Doesn't cause as much harm to cement, obviously, but things like wood and rubber are damaged. Causes extensive damage to plant life. So not just house plants and trees and the environment, which is a big problem, but also agriculture. So areas where we would like to have agriculture in close proximity to urban centers, those plants are usually less productive because of the extensive damage from pollution. It can also cause a whole myriad of birth defects, from low birth weight being the most or the least severe to total deformities, which is the most severe. And then emphysema, asthma, and other respiratory issues, these all increase. It reduces your body's ability to breathe in oxygen and process things. It damages the esophagus and the lungs, etc., especially under prolonged exposure. You should know these harms that go with the specific pollutants. Let's look at a case study here about China. China's been brought up a lot. It's the area in the world that is suffering the most due to air pollution right now. So let's look at these and think about these questions. What are the human sources of air pollution? You should know already. But what is the air pollution specifically? Identify specifically what it is. What is the harm does it cause? They're going to show you some things. And then this one, thinking really broadly, what are the costs? Socially, economically, environmentally. Very short video here.
Some areas that we have more vehicles that would be the major contributor for like NOx, hydrogen oxide and PM2.5. From the mainland China area, it could be from the industry, it could be from the power plant, it could be from vehicles, etc. So that is the combination of different sources to different problems that we are looking at.
所以这个比呢，可能差一点，但也差不大。
我感觉这边的话，空气比内地稍微好一点，雾霾也是可以，能见度还可以。
We should not just compare with like in Beijing or Shanghai. We should start from the health perspective. impact air quality. Both together will drive us to have a more rooftop increase. When government talk about the air quality issue, they will mainly focus on the concentration level, but the actual health cost is not really highlighted. The general public may not really recognize the health cost could be huge. They have cold, they have other issues that they can do. I think that is the one thing that can experience that they don't really recognize. That is purely from life activity.
Okay, on this last question on here, economic and environmental costs. It's key stuff. Turn to a neighbor. I want to talk this out for a couple minutes here. This isn't just, oh, there's some smog and so I'm coughing a little bit. These effects have huge ramifications in, I'll just give you the magnitude in the United States is in the billions of dollars. In China, it's in the tens to maybe as much as $100 billion per year of influence. How do we come up with those numbers? Think about what it is. That's just the money cost, but the environmental cost here usually doesn't have a dollar figure. But how do we come up with those kinds of numbers? Talk it out. I want everybody to turn to person and come up with one or two things for social, economic, and environmental impacts and costs associated with air pollution. Go. All right, give me some stuff here. Who can give me something for a social cost? Give me something specific. Should be easy, right? Just talked about it. Eric, what do you got? He says housing and industrial settings. Give me a little more.
Housing is typically, there are like racial issues that cause people to live where they live today.
Environmental injustice, racial issues, minorities end up having to live in places where it's worse. Is that what you're referencing? Good. Yeah. Environmental injustice, that's huge. That's a key word that you should be thinking a lot. Yeah. The air is fine. How about this? If you have an immunocompromised person in your family and now they're dying, what do you have to do? You have to take care of that problem. Do you have health care costs? For sure. All that is social. You're going to have to give me some very specific things like this in order to get credit on these types of questions. What about economic costs? How does this influence the economy? Yeah.
It's not safe to go outside. Like some businesses and stuff wouldn't have any customers.
Safety issues also causing businesses to have declined because of not wanting to go outside. You have to pay for all the health care. Definitely not insignificant. That chunk of that money that I gave you is from those sources.
It's going to be expensive to remove some of the smog and try to clear it from the city.
Expensive to remove it, yeah. reduction in tourism, agriculture production declines. All of these things. If you're not taking notes, you probably should be. These are good examples that you're going to want to reference later. Yeah. Pay taxes to pay for regulations or for removal, for sure. What about the environment? This one should be the easiest one, but be specific. Yeah.
Throughout the year, when there's, we said 150 days without sunlight, that's roughly a third of the year that's going to be just completely off.
Reduction in sun, reduction in primary productivity. What happens if you reduce primary productivity? Every other level of energy goes down. You have all kinds of problems. Ecosystem services, things like fresh water associated with forests. Be specific. All right, we're going to do one quick exercise to round out our time. I feel like I'm going blue in the face about this kind of thing, but we need more practice. We need diligent and focused practice. Here's a good opportunity. A real question from the 2009 AP exam. How specific do they want you to know? Well, they want you to be able to actually identify secondary pollutants off the top of your mind. You have it in your notes right now, so it should be a lot easier to reference. Everybody answer this question. We're going to go close it out with this final 3 minutes to answer. This isn't the whole question. This is about half of it. But attempt this question. Go.